right, guys, so we are going to continue our 1.1 notes and we're going to pick up on in behavior. So it says here, in behavior is as your x values approach either the positive or the negative infinity, what are those y values approaching? And that's exactly how we're going to write it. So looking at this first graph, as my x's are approaching, we use a little arrow for the word approach. So as x approaches infinity. So as my x values are going to positive infinity, where are my y values going? The y values are approaching positive infinity. So as that graph goes to the right, it is also going up, 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 and away. So as x approaches positive infinity, y is also approaching positive infinity. We also want to make note of what's happening to x as it approaches negative infinity, positive or negative infinity. So as x approaches negative infinity, those y values are still going up, 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 and away to positive infinity. It doesn't matter if you switch these around and do your negative infinity first for x or the positive infinity, but I do need you to write both of them, okay? Looking at the second one, as x approaches, let's go negative infinity this time. So now we're looking to the left. Where are those y values going? They're going up, 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 and away. They are going to continue to approach positive infinity. As x approaches positive infinity, what happens to those y values? They're going down, so those y values are approaching negative infinity. Notice it's important that these arrows are on the graph. If the graph doesn't have arrows, it could be approaching a number, like, if it's approaching 2 or it's approaching 5. But both of those graphs have arrows, so it's either approaching positive or negative infinity because it's going to keep on going forever and ever and ever. All right, this would be a great time for you to pause and try to do the last two on your own. So I'm going to go ahead and say as x approaches, I'll go to positive infinity first, y approaches negative infinity. It is going downward. As x is approaching negative infinity, y's are still approaching negative infinity. It's going down. The graph is going down in both directions. So it's approaching negative infinity as x approaches positive and negative infinity. The last one's going to be a little bit different. As x approaches positive infinity, y's are approaching, you got it, positive infinity. Look at when x is approaching negative infinity, though. Look at what's happening. What is happening to our graph? It does have an arrow, but it is approaching some number. It's not going down. It's approaching some value, and that value is 0. Okay, so that's what I was talking about earlier. It can approach a number. It doesn't. Sorry, I just kicked my laptop out. It doesn't always have to approach positive or negative infinity. It can approach a number. Going to the second page of our notes, we're going to be talking about our global maximum and minimums. And another word for global that we use is absolute. And that maybe will help you remember what this word means a little bit better. It is the absolutely highest or lowest point on the entire function, on the entire graph. Okay, and so it says for that minimum or maximum value, the x value of the coordinate is where it occurs. X value is where it occurs, and the y value is the value of that maximum or minimum. So we could ask questions differently for global max and min. We could say, where is the global maximum located? And that you would give us the x value. We could say, where is the global minimum located? You would give us the x value. But if we asked, what is the value of that global maximum or of that global minimum, then you're going to be giving us the y coordinates, okay? So in example 3, it says find any global or absolute. Those words are going to be interchangeable, minimums or maximums. So just because it doesn't say specifically in our directions if we're listing where or the value, I'm going to go ahead and list both, but it will be very concrete on a quiz or a test. It'll say, where is the absolute or global min or max, or what is the value of that absolute or global min or max. So let's look at the first picture. Remember, absolute or global minimum is going to be the lowest of the lowest point on that entire graph. The global or the absolute maximum is going to be the absolute highest, the highest of the highest point of the entire graph. So for my minimum, it is located at the x value. Where is it located? Well, this is the lowest of the lowest point on this entire graph, and the x value is -1. The value of that minimum is the y value, and the y value is -3. Okay, so minimum, this is the lowest of the lowest point on the entire graph, right? Because on both sides, you have arrows pointing up. So they're going to keep on going up, 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 and away. So the lowest point is it's located at -1. Its value is -3 because that coordinate location is -1, -3. Okay, now let's think about the maximum. The global maximum is the highest point on the entire graph. Well, where is that coordinate location? Guess what? We don't have one. Why do we not have one? Because we have arrows pointing up in both directions, okay? Both ends of the graph are going up, 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 and away. They are going towards infinity. There cannot be a highest point if our graph is approaching positive infinity. So there is no maximum on this graph, okay? Let's look at the second graph. Is there a highest of the highest point? Is there a maximum? Is there a global or absolute maximum on this graph? No, because it is approaching infinity. It keeps on going and going and going up, 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 up. So there is no highest of the high. None. Is there an absolute or a global minimum? No, because this side has an arrow going down, so it's going to negative infinity, so it doesn't have a lowest of the lowest point, so it has neither a global max or min. Okay, now I know this is the highest point in the vicinity, and this may be the lowest point in the vicinity, but that's not the highest point on the entire graph, and that's not the lowest point on the entire graph. We need to remember that absolute or global is on the entire graph, okay? So let's look at that third graph. That third graph does not have arrows. So this is going to be a kind of a game changer. If it doesn't have arrows, we know for sure that it's going to have a global max and min. Okay, so where is that global or absolute maximum value? Well, the highest point on this graph is that endpoint. It's right there. So where is it located? It's located at 18 because that's the x value. What is the value of that point? The value of that point is the y value, which is 3. Watch your scale there, okay? It's 3. Now let's look at the minimum. The absolute or the global minimum. It's the lowest of the lowest point on this entire graph, and that would be right here, right there. So this is the max, this is the min. Where is that minimum located? Well, we're looking at the x value. The x value is 13. What is the value of that point? That's our y value. So we got to be careful here. We're looking for this y value. They are counting by quarters. So this is 1/4, 1/2, 3/4, and 1. So at 0.75 or 3/4. However you want to write that, it does not matter to me. Okay. All right. So global and absolute, those words are going to be interchangeable. We're looking at the entire function, the entire graph, looking at the highest or the lowest point. X value is where it occurs. Y value is the value of it. The last thing we're going to discuss is increasing and decreasing in positive and negative intervals. So intervals are on a graph referred to the x values. So anytime I ask you for an interval, I'm only wanting you to list those x values, okay? Increasing and decreasing. Obviously, you've heard these words before. Increasing means it's going up from left to right. Very important that we read our graphs from left to right. So if our slope, if that rate of change is positive, it's going up from left to right, then that is increasing. It's decreasing if from left to right it's going down, or it has that negative slope or rate of change is negative. From left to right, where are the y values increasing or decreasing? And then we also have positive and negative intervals. Again, reading from left to right. Positive means it's going to have a positive y value. So that means it's going to occur, it's going to be located in the first two quadrants. Remember, this is quadrant 1, 2, 3, and 4. So in the first two quadrants, that is above the x-axis, that's where our graph is positive because the y values are positive there. If it's negative, if we want that negative interval, then that's going to be happening in these bottom two, the third and the fourth quadrant, because that's where our y values are negative, so below the x-axis, okay? So increasing and decreasing intervals, like we said, all intervals, we're only going to be listing the x values, whether that's increasing, decreasing, positive, or negative. We're only going to be using our x values, okay? Increasing and decreasing, we are always going to be using parentheses, okay? So let's take a look at this first graph. I want to read from left to right, and I want to see where it's increasing. So I see that because there's an arrow here from negative infinity all the way up to this x value of 1, it is increasing. But the graph doesn't stop there. It starts to decrease, and then it goes up again. Notice that's a positive slope here. So from this x value of 3 all the way to this x value of 5, it is increasing. Okay, so I'm reading from left to right and seeing where my graph is going up because I'm looking for increasing. So because there was an arrow here, this is like it's keep going down, 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 down. So from negative infinity, my x value, negative infinity, all the way up to this point right here of 1. And remember the symbol union, and from this x value of 3 all the way up to that x value of 5. I know that the graph is stopping at 5, but notice we do not use a bracket there, okay? We're always going to use a parenthesis for increasing and decreasing, because at that point of 5, when x is 5, is that graph really increasing? No, it's constant. That's one single location, okay? So that's why we use a parenthesis. Now let's do our decreasing. So kind of the opposite. Where is it going down from left to right? So the only place that this graph is going down from the left to the right is from the x value of 1 to the x value of 3. Okay, and look at your intervals of increasing and decreasing and string them all together from left to right. Negative infinity to 1, 1 to 3, 3 to 5. That's where my graph ends. Okay. My graph goes from negative infinity all the way to 5, and all of those values are accounted for in the increasing and decreasing intervals. Now let's switch over to positive and negative. Positive and negative those intervals can use a bracket if applicable. When is it going to be applicable? If it starts or stops in that positive or negative realm. What do I mean by that? Notice this graph has one arrow, but it does have a stopping point. That stopping point is in quadrant 1, so that means it has a positive value. So I can cap it. I can use a bracket to end that interval at the x value of 5. So let's string it all together. Where's my graph positive? Anything above this x-axis is positive. So I'm looking for where that graph is above the x-axis. And it's above the x-axis starting at 0 all the way to 2. I'm not going to include those values. I'm going to use parentheses. Why? Because when x is 0, y value is 0. And is the y value of 0 positive or negative? Well, it's neither. The number 0 is not positive and it's not negative. So I cannot include those values because add that x value of 0 and that x value of 2, the y value is 0 and 0 is not positive nor is it negative. Okay? So from 0 to 2 it's positive. It's also positive from 4 to 5. 4 has a y value of 0, so it's not positive. But 5 has a y value of 2, which is positive. So I can include that x value of 5. So that's why I put a bracket there. Okay, and it may be a little confusing in the beginning, but once you do more examples, it's going to make more sense. Negative, we're looking below that x-axis. So obviously all the way from negative infinity to 0 and 2 to 4. Remember, we're only listing the x values in the intervals. The y value will determine if it's positive or negative, if it uses the parenthesis or the bracket, etc., etc. Notice 0 as an x value has a y value of 0. That's not negative. I cannot include it. An x value of 2 has a y value of 0. Not negative. Can't include it. X value of 4 has a y value of 0. That's not negative. I cannot include it. So I'm using parentheses for that whole set of intervals there. If you would like to pause the video and try to do the next example on your own, I would strongly encourage that. But here I go. Increasing and decreasing, going up from left to right. So that means from negative 6, the x value, negative 6, all the way to that x value of negative 2, my graph is increasing. Okay? Nowhere else is this graph increasing. I'm going up, I'm going down, and then I'm remaining constant. Okay? So that is the only interval for increasing on this graph. Where's this graph decreasing? Going down from left to right. X value of negative 2 to an x value of positive 2. Negative 2 to positive 2. Done. Okay. The rest of this graph is remaining constant. So if I had to ask, where's the graph constant, then you would say from, you got it, 2 to infinity. And you would use parenthesis 2, comma, infinity, parenthesis. Very good job. Positive intervals. We want to know anything above that x-axis is positive. So what's my x values? Well, it crosses that x-axis right here at negative 3.5. I'm going to use a parenthesis because that y value is 0 and 0 is not positive. So from negative 3.5 till what? This point right here, which it's kind of hard. We're going to have to estimate a little bit, and that's okay. It's definitely not going through at a half. It's closer to negative 1. So maybe you want to use like 3/4 or, whatever, 5/7, whatever fraction you feel that kind of fits. And, this is just an estimate. We're going to talk later about how we could find those values exactly. But for now, we can just estimate, and I'm going to say it's about negative 0.75. Okay? So positive, anything above that x-axis. So from here to there. Even though it's decreasing, it's still positive. All right? Don't confuse increasing and positive and decreasing and negative. You can be increasing and negative. You could be decreasing and positive. That is totally a thing. Now we're on the negative, so I'm looking at anything below my x-axis. Okay, so I know that I'm starting at negative 6, and that is a starting point. There's no arrow there. So it is totally included in that value because its y value is negative 5. Okay, so from negative 6 all the way up to that point that we said earlier of negative 3.5, parenthesis, and this is negative, and it's also negative here. All this is negative. So from that same point, that negative 0.75 all the way to infinity because there's an arrow here. It's negative. Okay. The last question is just kind of incorporating a couple different things. It says use the graph of f of x, so that's the notation for a function. Hopefully you saw that in algebra 1. Use the graph of f of x below 2, and the first part says we want to evaluate f of 2. So we read that as f of 2, and that means when my x value is 2, what is the function value? Well, 2 is here, right here. When I go up, I see a hole, but I also see a solid point. The hole is not going to give me the value because it's like it's not there. So I want to go with that solid dot, and that solid dot has a value of 3. So the point 2, 3 is on that graph right here. When x is 2, the y value is 3. You always want to go with a solid dot. So what about if this wasn't there at all? Watch, let me do this. What if this wasn't there at all? And I said evaluate f of 2. You can't. There is no function value when x is 2 because it's an open dot. Okay? All right. Find all the values where f of x is equal to 1. We want to know what x values give us a y value of 1. Y value of 1, it could be any of these x values. We see 2 of them that this function has. When my y value is 1, I also have an x value of negative 1. And right here, when y is 1, I also have an x value of 1. And you can put, x equals, or you can just list them out like that. So be careful with those first two. If the number's inside the parentheses, that's an x value. If the number's after the equal sign, that is a y value. Last one is your average rate of change. And another word for that, like we said, is slope. You got it. So slope, how do we find slope? It's rise over run. That is your average rate of change. Now, notice they give us an interval here. -2, 0. That is not a coordinate location. That is an interval. Intervals are always listed in x values. So if they're giving me the x value of -2 to 0, then they're talking about this portion of the graph. This portion of the graph. Okay? And so you could definitely count your rise over your run and import those values and simplify. But you also know that slope is calculated by the change in y. So that would be like y2 minus y1 over the change in x, x2 minus x1. So you could also use the coordinate location of 0, 0 and -2, 4. So whatever you feel more comfortable with. Maybe you want to just count your rise as 1, 2, 3, 4, and your run is -2. So that would give you a slope or an average rate of change of -2. If you want to use in those values, you might see something like 4 minus 0 over -2 minus 0. And you're still going to get -2 as your average rate of change. Okay, just be careful. The interval is given with x values. That is not a coordinate location. So you're finding the average rate of change between those 2 points. When x is -2, that point here. When x is 0, that point there. Okay. Hope this wasn't too boring or too confusing. Let me know if you have any questions. Bye.